When we have equations with multiple logarithms in the same base, we use the log rules to combine them. This puts us actually in a slightly nicer position than we were, if you'll recall, when we had multiple radicals. Dealing with multiple logs, as long as they're in the same base, is not too hard, as long as we remember our log rules. So first, we'll collect all of our log terms on one side and all of the non-log terms on the other. So here I have one log term on the left, one log term on the right, and then a number. My first move is going to be to subtract this term from both sides. So now I have only log terms on the left and only numbers on the right. Now that they're on the same side of the equation, I can use log rules to combine these two. We're subtracting. The difference of the logs is the same as the log of the quotient. So I'll have the log base 3 of the fraction x plus 2 over x minus 6. And that's equal to the 2. Okay, so now I have a log equals a number. It's a slightly more complicated log than I had before, but I can now make exactly the same move that I made when I started with an equation with a single log in it. That is, I can rewrite this in exponential form, and I'll be left with the argument of the log equals the base to the second power. Right, so that's just rewriting the log in exponential form. Now, the good news is we no longer have a log equation. The bad news is we now have a rational equation, an equation involving rational expressions. We need to remember how we solve one of those. So I have the equation x plus 2 over x minus 6 equals 3 squared is 9. I need to get rid of this variable in the denominator, so I'm going to multiply both sides by x minus 6. On the left, those cancel out, and I just have x plus 2. On the right, I have 9 times x minus 6. So x plus 2 is 9x minus 54. I'll add 54 to both sides and subtract x on both sides. Divide both sides by 8, and I get x equals 7 as my solution. Now, I've made strange new moves in solving this equation. I would like to check that that was correct. So my original equation was log base 3 of x plus 2 equals log base 3 of x minus 6 plus 2. So when I plug in x equals 7, the log base 3 of 7 plus 2 is the log base 3 of 9. 9 is 3 squared, so this is 2. The log base 3 of 7 minus 6 plus 2, that's the log base 3 of 1 plus 2, The log base anything of 1 is 0, so this is 0 plus 2, which is 2. So both sides of my equation do indeed work out to 2. That really was the actual solution to this equation. And even though this technique works, that actually isn't a foregone conclusion. In the next video, we'll talk about how this move where we combine logarithms has the potential to introduce extraneous solutions.